All right, in this question, we are calculating the equilibrium constant, and we're given some starting values. We're going to have to do some conversions to put those into molarity, but we're given moles and liters. And then we're given one value at equilibrium. So we can't, this isn't just a plug and play where we write the equilibrium constant expression and then fill in all the concentrations. But it's also not a full ICE table where you got to use the quadratic formula to solve for what X is. Here you can solve for X using the one given value, which is this one, 6.7 moles, which is over that same 50 liters. And so I'll show you what that looks like for this type of problem. So first thing I'm going to do is convert from moles and liters to molarity. So for, or let's write our balanced chemical equation to start. So we got steam reforming. So we got water reacting with CH4. To form, it says, carbon monoxide and hydrogen. Remember, that's a diatomic. So we got one carbon on both sides, we got one oxygen on both sides, and then we got 6 hydrogens and 2. So we're going to put a 3 here. So there's our balanced chemical equation. Now I'm going to do a little conversion. I got 6 moles per 50 liters equals 0.12 molar CH4. I got 3.7 moles per 50 liters equals 0.074 molar for H2O. And then my final equilibrium concentration is 6.7 moles over 50 liters equals 0.134 molar. And that's at equilibrium. Now, we still, because we're given initial values, we still need to do an ICE table and fill that in. We also have to write our expression. So our expression here would be concentration of CO, H2 to the third, okay, but we don't know those. The only value we know is H2O. So we got to find those other ones. So we got CH4, we got H2O, we got CO, and we got H2. So I'm going to say my initial is 0.12. Here I have 0.074. Here I have 0. Here I have 0. So I know it's going to progress in this direction because I have no products. So we're going to have a plus X and a plus 3X here. Now remember this, right? Just like rates, this acquires X 3 times as fast as CO because there's a 3 in front of it. So you're getting 3 moles of H2 for every 1 mole of CO. So we're going to have that 3X. And we also have the cubed. So double effect there. Here we got a minus X and a minus X. So my equilibrium values are 1.2 minus X, 0.074 minus X, and X and 3X. And this is, that's my value for H2, sorry, not H2O. Okay, so now what do I know? So I can't plug all these in and solve for K. I need to know what X is. I don't need, when you know K, you can use a quadratic formula to solve for, but here I don't know K, I'm solving for K, but what I do know is the value of this. So if the value, so 3X is equal to 0.134 molar, which means X is equal to 0.0447 moles. So we know what the concentration of hydrogen is. We know carbon monoxide is 0.0447. And then we can do some subtraction. So 0.12 minus that value gives us 0.0753. And then 0.074 minus our 0.04 gives me 0.0293. and then make sure you're using this value for the H2. So I'm going to plug all those in. Getting crowded here. So we got 0.0447, 0.134 cubed, 0.0753, 0.0293. And then I got to solve for K. Now make sure you're not an easy calculator problem. And I get K equals 0.0487. And it says to go to 2 significant figures. Okay, so let's try 0.04. 0.49. There we go. So a lot to it, but a little bit simpler than the quadratic formula method in that we're given a way to solve for X, but still, big part of this is what is the question asking me? How do I convert to molarity, a concentration unit? And then I got to use my icebox to solve for this X with the given amount. Notice it says it's come to equilibrium and measures to be this much. So that's telling you how much equilibrium, whereas the other ones are telling you initial. So if it's all initial and no equilibrium, it's probably an ice table quadratic formula. If you're given initial and one equilibrium, then you can use this method.